In today's lesson, I'm going to do how to find the area between two curves. So I will be using calculator and also do a few questions by hand. So the first one is when f of x or y is equal to 4 minus x square, and the another one is y is equal to x plus 2. And you have to find the area bounded by these two curves. Now to do that, first step you should do is you graph these two functions. You should know how to graph the quadratic and linear function by hand. And if graphic display calculator is allowed, you can also use GDC. It's just a sketch, so you don't have to be like exact with the graph. But the first thing you need to do is you graph these two. So here I can see this is parabola which opens down. This opens down because you have I can rewrite this as negative x squared plus 4. So the negative coefficient of x squared means the parabola opens down, and then the vertex from here, because if I compare it with ax minus h whole square plus k, then the vertex in this case is 0, 4. So I know the vertex here, and then I can also find the x-intercept easily, because here you have 4 minus x squared. For x-intercept, y will be 0, which means x is going to be plus minus 2, so negative 2 and 2. And then you can sketch this one, or you can use the calculator if calculator is allowed here. Now the second step is to sketch y is equal to x plus 2, which is linear. Now from here also you can find when x is 0, your y is 2. So when x is 0, this is 4, y is 2. And when you have y is equal to 0, x is negative 2. So we found x-intercept and y-intercept, and you can use that to graph it. Now you have to find the area which is bounded by these two curves. Bounded means which is enclosed by these two curves, and clearly the area which is bounded by these two curves is this much, this one. So you have to find this area. Now how do we find the area of this? We need to first see the intersection point here, this one and this one. So here we know that your x is negative 2, so that is negative 2, 0. So this point we know is already negative 2, 0. And this point is, we can find this point again if you are using GDC. If GDC is allowed, then you can find the point of intersection using GDC. And if not, then you can also do it by hand, which is quite easy to do it because both of them is y, so you can equate them. And then you get here, I'm going to move everything on one side. I want the coefficient of x squared as a positive, so I'm going to move this there. So that means 0 is equal to x squared plus x plus 2 minus 4. So x squared plus x minus 2 is equal to 0. And if we factorize it, so we'll get here, this is negative 2 and plus 1, so x is equal to 1 and x is equal to negative 2. So negative 2 was this point, x is equal to 1 will be this point. So 1 comma, if I substitute 1 here, so this is 1 comma 3. So now we need to find the area of these two curves from x is negative 2 to x is equal to 1. So how do we find? For two curves, to find the area, we use integration. So negative 2 to 1. So the lowest value is the lower limit, and then 1 will be the highest, will be the upper limit here. 1, the highest value will be the upper limit. Negative 2, the lowest value will be the lower limit. And now we need to see that when we are finding the area which is enclosed by these two curves, so we'll see which one is above. So the quadratic, the parabola is above. So if I find the area under the curve of this, which I am doing like this, and then I will subtract the area under the linear function, which will leave me with the area bounded by these two curves. So the area which is in red. So the above we have is 4 minus x squared, and then minus the linear function is x plus 2. So this is what we need to find, the area of this. And now we can simplify it. So negative 2, 1, 4 minus x squared minus x minus 2. Again, if it's by hand, you need to do that, simplify it. So I will get here negative x squared minus x plus 2 dx. And now you know how to integrate this. So this is minus x cubed by 3 minus x squared over 2 plus 2x. And then you will substitute the upper limit first. So minus 1/3 minus half plus 2, use bracket, then subtraction and lower limit. When you substitute -2, this is going to be negative and negative positive because it's x cube. So that is 8/3. And then this is minus, this will stay minus here because -2 square will be 4, 4/2 is 2, and then -4. So when you simplify it, you will get your answer, which in this case is 9/2, which is 4.5. You can do these calculations yourself. Now, if I want to do, I want to check it using the calculator. So I can also enter this y1 as 4 minus x square, and then I have x plus 2. So x plus 2, so I can graph, and then I can find the point of intersections. So to find the point of intersection, after you graph it, you go to second trace, which is calc, and then you go to intersect, and then you move your cursor to the intersection point, enter 3 times, and then you get the intersection. X is 1, y is 3. Similarly, you can find the second intersection, which is here. After that, now to find the definite integral, we can again use calculator. If calculator is allowed, you go to math, and then you go to number 9, which is function integral. Sorry, we need to quit this graph. So second mode, you quit. And now you need to go to math. And then we go to function integral, which is number 9 in this case. And now we'll start integrating because we already know the function. So we can enter this function, the function which we simplified. So -2 to 1, -2, 1. You don't even have to simplify if you don't want. You can enter as it is. So you can have bracket 4 minus x square, and then close the bracket, and then you have minus, if you don't want to simplify, x plus 2, since you are using calculator here, and then dx, and then if you enter it, it gives you 4.5, which was our answer, 9/2. So we got exactly the same answer here. So I did this question both way, by hand as well as using calculator here. Now, moving to the second question here. So next question is, find the area of the area which is bounded by the curve e to the power of 2x plus 1 and x plus 4. So this question is using GDC, which means you can use GDC to sketch this one. So I'm going to use GDC here to sketch this graph. First clear, and then e to the power of, so you will have here e to the power of 2x, and then plus 1, so you need to be out here, and then x plus 4. So this is your x plus 4. And if you graph it, so first step again, you need to sketch the graph. So I can sketch this graph here, something like that, and then you have this. Now we need to find these intersection point, and you know how to do that. So you go to second trace and then intersect, and now you move the cursor closer to that one, enter 3 times, and then you get the intersection. In this case is 0.647. So x point is 0.647. Y point you can also write down from here. We don't need that. And then we are doing the same, second trace, intersect, and then move the cursor again here. And then enter, enter, and enter. And then you get here -2.997, which is going to be -3, approximately -3 here. Now you need to find the, or if you don't want to use -3, you can use 997 here, and I can use 0.6469. So it's better to use 4 decimal places here. Now to find the, again the area which is bounded by these two curves, which is this one, the shaded one. So we do the same thing, -2.997 to 0.6469, and now we need to see which one is above. As you can see from here, this is, so it's better to properly label it as well. So this is x plus 4, this is e to x plus 1. So x plus 4 minus e to the power of 2x plus 1 dx. So you enter this in your calculator. If it's a GDC, you should be doing it using calculator. So I'm going to quit and then go to math, and then you will go to function integral, which is number 9. And from here, you will start substituting your limits. So negative 2.997. And then the upper limit is 0.6469. And then you have here x plus 4 minus e to the power of 2x. So you have e to the power of 2x plus 1 and close the bracket dx. So you got so we got approximately 4.83 units square. So whatever is the units given. So that is the area you got using calculator here. Okay, so the next one is again this similar concept here. Find the area between the curves. So you have x cubed minus 3x squared plus 3x and x squared. Again, using GDC, you can sketch them. So if I have here, let's clear that and enter x cubed to the power of 3. Sorry, this is x cubed minus 3x square. So your square is here plus 3x, and then you have x square, and now you graph it. So if I just sketch it, so it's going to be something like that, and then you have another one. So second is the parabola. So you are getting here like this, and then you get like that. So there's another intersection here. Okay, so the area which we have to find now is this one and this one. So we have to find two areas. Let's say this is A1 and A2. Now there are two ways to do this problem. The first one is, let's have a look at A1 here. So the A1 in this case, we need to first find the point of intersections here. This one, and that one. So let's find out. This one is here. So this point is 0, 0. And now we need to find these two. You can do it by hand, but since the calculator is allowed, you can also use calculator. I'm going to first do by hand here. So 3x squared plus 3x is x squared. And you get x squared minus 4x squared plus 3x is 0. X is common. Plus 3. So 1 is x is 0, which we already have. And then x squared minus 4x plus 3 is 0. So this is x, 1, 3, both negative. So x is 1 or x is 3. So this point is x is 1. This one is x is 3. Again, you can find y using x squared. So this is 1, 1. And this is 3, 9. And again, you can also use calculator to do that. So here, you know how to do that. Second trace, and then go to intersect. And then you can move your cursor and 3 times enter, and then you get x is equal to 1. Similarly, you go to second calc again, intersect, and then you go to the second intersection point, and then enter 3 times again, and you get x is equal to 3. Now, if you notice from 0 to 1, which is A1, so A1, your A1 is 0 to 1, and in this one, you have x cube graph, which is above x square. So in this case, you will have x cube minus 3x squared plus 3x minus x square dx. And for a2, you will have 1, 2, 3, and in that one you have x squared graph, and then x cube is below, plus 3x minus x squared dx. Now you enter these, and then after you find the value of a1 and a2, you just add them. That will give you the total sum. So this is one way of doing it. Now I'm going to show you again. So you go to math and then go to function integration. Okay, so we need to quit the graph, go to math, function integral, and now we are going to start with 0 to 1, and then we'll have here, I am going to simplify this. So this is x cubed minus 4x squared plus 3x. So we will get here x to the power of 3 minus 4x squared, and then you have plus 3x and dx. So this is the first one, and then you can have plus, again go to math, function integral, and now this time it is 1, 2, 3, and then you have, if I simplify this again, so this is going to be x squared minus x cubed plus 3x squared. Oh, okay, sorry, this was not x squared here. So this one is x squared minus x cubed plus 3x squared minus 3x dx, and you get minus x cubed plus 4x squared minus 3x dx. So minus x cubed minus x to the power of 3, and then you have plus 4x squared and minus 3x. No, sorry, this need to be clear, 4x squared and then minus 3x and dx. So this is x here, and enter. So you get here approximately 3.08 is your answer. And if I 0.83, or if we want 3SF, then 3.08 here. Now there is another way of doing it. If you do not want to deal with two different integrals, what else you can do is, we can find, ignoring which one is above and which one is below for these two sections, what you can do is you can find the area from 0 to 3, but using the absolute value. So what else you can do here is, if we go to math and function integral, and then you will do 0 to, because another upper limit was 3, and then you go to second 0, catalog, absolute value, and now you enter your two functions. It doesn't matter in which order you want to enter. You can start with x cubed minus 3x squared, x to the power of 3, minus 3x squared plus 3x minus x squared dx. So it doesn't matter. If you want to start with x squared, you can do that also, and then press on enter, and you should get exactly the same value. So you can also do using the absolute value here. So that's it for today's lesson.